minimum sum of the products for f of w comma x comma y comma z shown in Karnaugh map below. K map means what? Karnaugh map, right? So where Karnaugh is an author. So they have given some expression, some table, K map, right? What is output this one? Right? What you can do simply, you can make sure to combine maximum subcube of size 2 power m, right? What is the maximum size of 2 power m? Maximum size it is possible from the given data, right? So can I combine these two? Guys, try to observe. I can combine these two, right? I can combine these two, right? But if you observe this one, why you are missing this one? Which is what? Maximum 4 size subcube. So this is actually main subcube is prime implicant. It internally contains what? These two sub, right? Can I call those two as a prime implicants? No. Prime implicants means what? It should not be subpart of other prime implicant. So I should not consider those two. So you have to get a subcube of size 4, right? What is the value of these two? Combine. So 0 is not changing. So you are going to get z bar. Here I think x is not changing. So you are going to get x. What about this 1 1? Can I do this 1 1 combine? Or do I need to use don't care terms? Can I do it with don't care terms? Yes. Now what is the expression you are going to get? I think 0 is not changing on the x axis. So you are going to get x bar, and on the y axis z is not changing. That is also normal variable zx, right? Z bar x plus zx bar. Is there any answer is there? Z bar x plus zx bar. Yes, option B is the correct answer.